All right, so we're working on the test 3 review, and on number 9 we are adding two fractions that have a like denominator or common denominator. In fact, we know when we add or subtract we have to have a common denominator. That's not true with multiplication, that's not true with division, but with addition and subtraction we need a common denominator. So here, well, one thing we learned is you don't leave, or you basically leave the denominator alone. And we add the numerators. So a plus 2 goes here. Now you might be tempted to stop at this point, but look at our denominator. It's a trinomial. So you should at the very least, consider factoring it. And so let's do that. There's a good chance there's an a plus 2 factor, by the way. So we need two numbers that multiply to -8 that add to -2. 2 and 4 are the ones that are going to work. Notice they multiply to a -8, so they're opposites. And they add to a -2, so the bigger one needs to be negative. So that's the one that's going to work. So we're going to have a plus 2 and a minus 4. So sure enough, we've got some a plus 2 factors we can cancel. Notice what's left. It's 1 over a minus 4. It's not 0 over a minus 4. That would be a 1. That's why it's important when you cancel to put those 1's in. What we're really saying here is if you divide by this number a plus 2, you get 1. And in the denominator, divide by that same number, a plus 2, and you get 1. A plus 2 divided by a plus 2 is 1. And so we're left with 1 over a minus 4. All right, on number 10, again, our denominator does not change. Now in the numerators, we're going to have to subtract. We have 5m minus 2 minus 3m plus 10. Whoa. Let's fix that fraction bar. Okay. Now be careful here because I intentionally didn't put in parentheses, but notice, I mean, it doesn't really matter here. We can put parentheses around the 5m minus 2 if we want. We don't really need them. We're going to drop them anyway. But here we're subtracting a binomial because this numerator is a binomial. And so we need parentheses here. Now I'm just going to go ahead and put it in both. So it's this numerator minus this numerator. So that's going to end up being 5m minus 2 minus 3m minus 10. So notice the negative changes both terms. We're basically distributing a -1. And in the denominator we still have m minus 6. So 5m minus 3m is 2m. -2 minus 10 is -12, and that's over m minus 6. Now again, you may be tempted to just move on at this point, but notice you could factor out a 2. 2 times m minus 6 in the numerator over m minus 6. So you can see that these m minus 6 cancel, and you actually are left with the number 2 as the final answer. All right. Now on problems 11 and 12, we don't have a least common or a common denominator. So we're going to find what we call the LCD, the least common denominator, for these two denominators here. Well, these are what I call algebraic factors. There's nothing that can be factored here. We have to treat x plus 1 and x minus 2 as single numbers. X plus 1 is a number, x minus 2 is a number. And to get an LCD, we just multiply them together. Now, we need a common denominator. We're going to rewrite the fractions so that they have this new denominator. Now I can't just change this denominator from x plus 1 to what I have here. What I basically need to do is multiply by x minus 2. Now if I just did that, that would be illegal unless I also multiply the numerator by x minus 2. That's what makes this legal because that's equal to 1. And so we're left with 3 times x minus 2 over x plus 1 times x minus 2. Now notice if we were to cancel the x minus 2, we'd be back to where we started. But remember, the whole point here was to get a common denominator, and so this is exactly what I want. Over here, I need to multiply the x minus 2 times x plus 1. So I'll do the same thing to the numerator. So it'll be minus 5 times x plus 1. So again, if you cancel this, you're back to where we started. We call this building fractions. We built these two fractions so that we have a common denominator. Why did we do that? So we can subtract our numerators. The denominator stays the same. I'm just going to write LCD to save some writing here. So we're going to have 3x minus 6, and then a minus 5x, and negative 5 times 1, that's minus 5, over the LCD. Just let me go down a little more. And so 3x and a minus 5x is negative 2x. A negative 6 minus 5 is negative 11. And my LCD, that was x plus 1 times x minus 2. All right. Hold on just a second. The only thing I would add is, sometimes people will put the negative out front, and this will be 2x plus 11, but this is a perfectly good answer. All right, I would encourage you to try number 12. Now keep in mind, this is something you can factor, and it'll help you as you find the LCD. Let's see how you did here. When you factor this, not surprisingly, you end up with an x plus 7 and x plus 6. Notice 7 times 6 is the 42, and 7 plus 6 is 13. We know that we can choose the numbers that way because this is a 1x squared. So our LCD has each of those factors, x plus 7 and x plus 6. Notice you don't have to multiply times the x plus 7 here. You just take each of the algebraic factors that you find in the denominator to the highest power found. Well, they were all to the first power. And so we'll just use each of these to the first power. Now, you'll notice that we don't need to do anything on the second fraction. It's already got the LCD for its denominator. But this one's missing the x plus 6 factor, so we're going to multiply by x plus 6, which means the numerator gets multiplied by x plus 6, so that'll be 3 times x plus 6 over x plus 6 times x plus 7. I've got these reversed, but it doesn't really matter. So now I have a common denominator. So when I add the numerators, my denominator will not change. We're going to have 3x plus 18 plus x minus 5. So we're going to end up here with 4x plus 13 over x plus 6 over x plus 7. Notice there's nothing I can factor out of the numerator, and we're done. Let's see, what did I do? Oh, I see what I did. All right. -5. Okay, so that's good. Let's move on to the next page. All right, so here we're solving rational equations. And in fact, we start similar to the way that we did with the last problems, but it's going to be a little different. In this case, our LCD is x. We only have one denominator, so that's going to be our LCD. But we use the LCD to clear fractions, not to get a common denominator. I'm not trying to get all x's in the denominator. So we find the LCD, we're going to use it to clear fractions, but we also have to look for any restricted values. Notice x could never be 0 because then 12 over 0, that's undefined. So we call that a restriction or restricted value. So now let's go ahead and multiply each term by x. So x times x is x squared. Notice x over x, these x's cancel, and you're left with 12 times 1, or just 12. On the other side, you have 8 times x. Now this is a quadratic equation, so you're going to want to subtract 8x on both sides. And be careful when you do this because none of these are like terms. We're going to put the x squared term, then the x term, and then the constant. 0 on the other side. So we need to factor this. It's going to be x and x. I need two numbers that multiply to 12 and add up to -8. It looks like it's going to be 2 and 6 that work. Notice they'll have to both be negative so that when you multiply you get 12, and when you add you get -8. So it'll be -2 and -6. When you set each of those equal to 0, you get 2 and 6. Now remember, we said x can't be 0. We didn't get that as an answer, so we're perfectly good. Now, the other way to write our answer would be this way, as a solution set. Either of these is fine. In my math lab, you'll have to do this. All right, so let's move on to 14. This one's going to be a little bit more work. First of all, notice that this is a difference of squares that can be factored as x minus 3 times x plus 3. And so our LCD will include those two factors. Notice that's also the factors we have over here. So again, we don't need to multiply these together. Every one of these factors is to the first power, and so we just use each one to the first power and we multiply them. So I'm going to multiply each of my terms, there's 1, 2, 3, by my LCD, x plus 3 times x minus 3. So notice when you multiply here, your x plus 3 is going to cancel with the x plus 3 here. And you're going to have 7x times x minus 3. Now let me get a piece of paper here. And let's do the next step. So you're multiplying x plus 3 times x minus 3 times this fraction. When you do that, the x minus 3's are going to cancel, and you're left with a plus 21 times x plus 3. Notice on the other side, the whole denominator cancels with our LCD, and we're just left with the 126. Now I just wanted to point out that if it helps, you may want to write x plus 3 times x minus 3 times 7x over x plus 3. So I'm just doing the first multiplication here because A lot of times people cancel and they're not sure why they're multiplying the x minus 3 times 7x. Well, it's because of the way we do the multiplication of fractions. You could multiply across, you'd have 7x times x plus 3 times x minus 3 over x plus 3. And then we could cancel the x plus 3's, and you'd be left with 7x times x minus 3. So notice that's exactly what we got here. So we're just canceling before we multiply. Once we cancel the x plus 3's, we're just multiplying the 7x with the x minus 3. That's what we're doing here. But again, if it's helpful, I would encourage you to write these steps out on some scratch paper to help you make sure you do the multiplications correctly. Okay, so let's go ahead and distribute. We'll get 7x squared minus 21x plus 21x plus 63 equals 126. Notice these guys are like terms. We'll get 7x squared minus 42x plus 63. And I want to get 0 on one side, so let's subtract 126 on both sides. Get 7x squared minus 42x minus 63 is what you're going to get there, equals 0. Now, the numbers are kind of big, but notice 7 divides into 42, and also 7 times 9 is 63, so we can factor out a 7. And in fact, when we do that, notice what we get here. This is one of those perfect square trinomials we've discussed before. Actually, you know what? Hold on a second. That doesn't look like it actually is a perfect square trinomial. I think there may be an error on this problem because this isn't a plus 9, so this isn't going to factor. We could actually, I'm trying to think, let's see, 7, 9, and 1. There's no way to get that done correctly. I'm going to have to disregard that problem there. I mean, the process is the same, but once we get to this point here, notice that we can't factor this. I was thinking this was x minus 3 quantity squared, but this needs to be a positive 9. So let's see, how would we fix this? Let's see, we multiplied here by x plus 3. All right, so there's something wrong here, so we're going to stop here, but normally what would happen at this point, we could factor this. Let's say this had factored as x minus 3 times x minus 3. You have 3 numbers that multiply to 0. It's not the 7 that caused that to happen. It's one of these x minus 3's, and you'd get x equals 3. And we would throw that out because notice our restricted values are 3 and negative 3 here. X can't be negative 3 here or 3 here. All right, so we end up with no solution here, but that's assuming that this was a plus 9. So again, there's something not right with this problem. I'm sorry I didn't see that sooner. Let's look at number 15. So on number 15, we have to cross multiply. Actually, before I go any further, I just want to say on 14, you could still see something like this, but when you get down to here, you will be able to factor it. All right, so here we want to cross multiply. So we know that 3 times 3x plus 2 is equal to 5 times 2x, or 10x. Doesn't really matter if you have the 10x on the left or the right. We're going to get 9x plus 6 equals 10x. Now, in a case like this, I need to get x on one side only. I would not mess with this x here because it's the only term here. I would subtract 9x on both sides. You can do it the other way, but it just takes an extra step. And students tend to make a mistake when they get 0 on one side with these. So notice we'll have these add up to 0. You're left with 6 equals x. And what can x not be? Notice x could not be 0. And you could maybe set this equal to 0, and you would see that x cannot equal, what's that, negative 2/3. Just set 3x plus 2 equal to 0, and when you solve, you get x is negative 2/3. Those are the values that would cause the denominator to be 0 in one of these two fractions. Notice we didn't get either of those, so our answer is 6. Alright, so I'm going to go ahead and stop this video right here. This will be the end of video 2. Hopefully there'll just be one